So the last video we looked at how to process and get elevation to it, but we've not really seen the elevation we converted from the last video. So this video we're going to import that into our GIS interface and look at how to do. But then if you check the data, it's not an XY data, it's not even an Excel data, CSV, but it comes with a format called GPX. So how do we get that? Because it does not look familiar. All right, so to dissolve that mysteries, like I told you in all my videos, you can either use, the tool, or you search. It's preferable when you know the tool, you just search straight to the point. So like I know the tool. So all I need to do is to search GPX, which is the format that came with that data. So once you search GPX, you're going to find out that there is a tool called GPX to futures. Now, if you want to know the origin of this, it's actually from GPS. That's the origin tool of it. So you just right click and go to locate in catalog. Now you're going to see from GPS is under conversion tools. So under conversion tools, there are quite a series of tools. So we have GPX to file, so to futures. So you double click on it. Now it's going to come up GPX to futures. So you're going to click on this folder like this, and you locate where your file is. You remember we save it in GIS folder, GIS training. So we have GPX, we have the date and then a data.gpx. So click on it and we'll click open. Now once it is open, they're asking for output future class. So you click on it, and this is actually stuff. So since it's boosted, so I'm going to put it here and I'm going to name it DEM. And then I'll click save and I will click OK. So the GPX to futures have successfully been converted. Now let's go and look at what we have. So you right click and you open attribute table. Now we have our attribute table up here. Now you see the name of it, all of them are labeled DEM path. Then the type is called TRKPT. I don't know what that means. Then comment nil, symbol nil, date nil. Then we have elevation here. So all the things we've clicked have generated an elevation, or have generated elevations of all of those points we may click into. So this is how you can actually generate an elevation of points you do not have idea of. This is just for knowledge base. If you're going to use this for any serious work, we surveyors use the autometric height. Now the height you get from this is ellipsoidal height, which is more or less a mathematical derivation. Now the autometric height comes from an observations using geodetic leveling for over a period of time, a long period of time, to determine an elevation of an area. So that data takes time to get. So most of the data we have from our total stations to, from our GNSS device to the GPS and all that comes from mathematical derivations. And then most people will tell you that those datas are they are good datas and all that, but that's topic for another day. But basically just know that ellipsoidal height are mathematical derivations. Those that claims your instrument gives you autometric height, I put it to you, it's a lie. Now what that does is that the GNSS receiver gives you ellipsoidal height. Now a model was created called geoid model and incited to that very device that it tells you it is it's autometric. Now the geoid model is a global model, especially we in Nigeria and Africa, we are disadvantaged. The geoid model in those devices are global model. In the US, you'll find out that each state has California, Texas, and all of those states have their joint model of each of these states. Now that gives you an edge. The data becomes higher in resolution compared to what has been sent down here telling us, and where the one forming it's accurate and all that. You can have your X and Y very accurate, but most of the times the GNSS device gives you a kind of off height because it's a mathematical drive height. And with the claiming of some of the device, I won't mention any product, some of the device that it has a joint model that can give an autometric height. That autometric height is using joint model, and joint model is also drive. So you drive an autometric height from a mathematical derivation. So all of the at the time of day, I believe the best device has always been the old device. So I can say boldly here that technological advancement in geomatics does not necessarily mean higher accuracy or better accuracy, but I can say for convenience, because you cannot really perform a survey between states using, let's say you want to take a level of about 50 kilometers. You cannot be thinking of using a level instrument to do that, will you? So it's basically convenience and not really accuracy. I just tried to make that argument on this video just to let you have a little bit of an idea of some of the things you're working on. So every data you're working on is based on understand first what the purpose of it is. Understand second, the kind of accuracy you're trying to achieve. Third, that at the end of the day, it is what you want that you will get. So thank you for staying tuned on this class. I just decided to chip in some of the geodesy and all that I've learned over time. So thank you for watching. I will see you in the next video where we are going to generate this into a raster. Stay tuned.